Afternoon. This lesson is from our Trig-Precalc class. This is going to be the first lesson in chapter 3. Before I get started though, I want to say I hope everyone is doing okay out there, and let's just go ahead and jump right in and talk about our goals. So I'm actually going to try and make today a story. I don't think I can really give a homework assignment about today. So the story that I'm going to talk about is I'm going to create the angles and the side lengths used for trig. There's going to be a lot more angles, obviously, that can be used for trig, but we're going to just create some of the basic angles and the side lengths used for them. And then the other part of the lesson is I'm hoping that you guys are going to understand how to graph angles on a coordinate plane. There's really no way to graph an angle on a coordinate plane. And so these are our two goals today, and I hope that I can achieve this by using some geometry concepts. So let's just review some things from geometry that will help us get to our first goal. The three angles of a triangle add up to 180 degrees. Okay. The second thing is base angles of isosceles triangles are equal. So if you have a triangle that has two equal sides, that's isosceles, and the base angles are at are made up of one of the sides that are equal. Those base angles themselves must also be equal, right? Bisect is to cut in half, and circles show equal distance. All right, so I'm going to start this lesson off by creating what's called an equilateral triangle, and I'm going to use a compass. I didn't mean to grab my Aloha compass. I wanted to use this compass. And a compass is a tool we use to make circles. And so what I'm going to do is I'm going to make a circle or half a circle. Okay, and I'm going to center it at that point. This is not going to stay on there. I'm going to center it on that point. I'm going to make about a half of a circle. I'm going to put another dot over here. And I'm going to make another half circle. Centered like that. And if I did this right, it should go through the point. Okay, that's close enough. And again, remember, circles show equal distances. And so if I connect this dot to this dot, and this dot to this dot, and this dot to this dot, I've just created a triangle that has three equal sides, an equilateral triangle, which is technically an isosceles triangle. All right, so let me draw this on here. Okay, so I've built a triangle that has three identical sides. And I was able to do that because I used a circle that has equal distance. So I know all three sides of this guy are the same. I also know that all three angles add up to 180 degrees. But this is also an isosceles triangle, so that means that this angle is the same as this angle, as well as this angle is the same as this angle. So what we can actually conclude here is that this triangle itself has three 60-degree angles. Okay? And so now what I'm going to do is I'm going to cut one of the angles in half. I'm going to bisect it, and I'm going to create three of the angles that we're going to need for trig. So let me bisect this and cut it in half. Make an arc. Make an arc. Draw this down. That's not very, that's actually, I think it's spot on. Take that back. That's actually really good. Okay, so I cut my 60-degree angle in half. So that means now I have a 30-degree angle. And since I know that the three angles of any triangle add up to 180 degrees, 30 and 60 gets me to 90, which forces this last angle to be 90 degrees itself. Okay, so I wanted to show you how we actually got a 30-degree angle, a 60-degree angle, and a 90-degree angle, or what this is supposed to be is our 30, 60, 90 right triangle. So let me go ahead and introduce you to it. This is our 30, 60, 90. If I write right triangle, I'm being repetitive. Okay. Now, let's just suppose that each of the side lengths on this original equilateral triangle had a side length of 1. So if this side length had a length of 1, and this side length had a length of 1, and this side length had a length of 1, we can very quickly argue that this little 30, 60, 90 triangle must be the same as this little 30, 60 degree right triangle. So what that means is that I can very simply conclude that this length right here must be 1/2. So let me draw this triangle off to the side here, and we're going to find the third side length of this. Okay. So this is 60, that's my 90, this is my 30. This has a length of 1, the hypotenuse has a length of 1, this leg has a length of 1/2. We need to find this length. And in order to do that, I'm going to use the Pythagorean theorem. So I know that question mark squared plus 1/2 squared, that'll be equal to the length of 1 squared. So I'm left with question mark squared plus 1/2 times 1/2, that's a 4th, and that is equal to 1, which I can say is 4/4. I can subtract the 1/4 to both sides, and now I have question mark squared is equal to 3/4. So like we saw before, I can square root both sides, and I get that question mark is equal to the square root of 3/2. I'm not including plus minus, all right? And I'm not including it because I'm not looking for numbers that make this true. I'm looking for length, and I can't talk about a negative length. So we've determined that this unknown side is square root of 3/2, and this is one of the triangles that we're going to be working with, the 30, 60, 90 triangle. I'm going to go ahead and create the next triangle here real quick. Let me do that. I was going to ask if there's any questions, but there's nobody here. Okay. So what I'm going to do for this triangle that I'm going to build is I'm going to build it in such a way that I'm going to start with a straight angle. Remember, a straight angle is 180 degrees. I don't think I really needed to talk about that fact. Okay. And in order to make this a straight angle, I need arrows, and I need a vertex. All right. So what I'm going to do is I'm going to bisect this straight angle just like I bisected that 60-degree angle. Where's my compass? Oh, there you are. I'm all over the place right now. All right, so let me bisect this. First I make an arc with a pen that doesn't work. Let me try this again. Hopefully this one works. Let me try this again. Let me make an arc. This pen's working. Look at that. Then I'm going to make 2 more arcs like this. And I connect my dots. And I've cut a 180-degree angle in half. And I've made a 90-degree angle. So I built a 90-degree angle. Okay? Now what I'm going to do is I'm going to use a circle to create equal lengths for the legs, and from there I can create the other angles and find the side lengths that we need. And I don't want to use that color because it's hard to see. Alright, so where did I hide that for myself? I hid it right here. Okay, so what I'm going to do, I'm just going to make a little half or quarter circle. Go like that. And what that means is it means that this length is the same as this length. And if I connect these points right here, I've made another very specific right triangle that I'm interested in. Let me erase the noise around this picture and just make a couple observations here. Okay, so again, I know that this side length is the same as that side length. And it's an isosceles triangle, so the base angles are equal. I know the three angles add up to 180 degrees. I have 90 of it, which means I have 90 remaining, which means that these two angles themselves must be the same. So these two angles are 45 degrees and 45 degrees. Okay? And now let's just assume for this 45, 45, 90 right triangle that the hypotenuse has length 1, and these lengths are unknown to us, but we know that they're the same. So I can find these unknown lengths. So I have the length I don't know squared plus the length I don't know squared, and that's equal to the length of 1 squared. Well, I have two I don't know lengths squared, and that's equal to 1. I divide away the 2, and the length that I don't know is equal to, the length I don't know squared is equal to 1/2, square root both sides. Let's do it like I did before. And now I get the square root is equal to 1 over the square root of 2. Well, I'm not allowed to have a radical in the denominator, so I need to multiply it by a very specific version of the number 1. This squares the radical away, and we get that the unknown length is equal to the square root of 2 over 2. Okay, so I know these lengths are the square root of 2 over 2 and the square root of 2 over 2. So I'm going to check off my first goal about creating the angles and the side lengths used in trig. I'm going to check this off. And I will go ahead and start part 2 of this video explaining how we represent 30-degree angles, 45-degree angles, 60-degree angles, and any combination of those angles added together on a coordinate plane. All right, so hopefully this is making sense to you guys so far. I will be right back. I'm back. All right, so let's move on to goal 2, understanding how to graph angles on the coordinate plane. I have a 30-degree, I have a 60-degree, I have a 90-degree, I have 45-degree angles, and I can graph any combinations thereof. So I drew the coordinate plane, and what I'm going to do is I'm going to draw a circle that has length 1. Okay, so whatever this circle is going to be, it's going to have a radius of 1. I need to make this a little shorter here, so that I can actually keep it on the whiteboard here. So I'm going to draw a circle, and again this circle is going to have a radius of 1, and that way we can start to see how the angles from these triangles get transferred onto the unit circle. So let me just add a couple things here. This is a 1, 0, right? Radius of 1. This would be 0, 1. This would be 0, negative 1. And this would be negative 1, 0. Okay. So, again, I want to start off, let's start off with a 30-degree angle. Right, so what this means is I'm going to take my triangle and I'm going to rotate it, right? So if I was to put a 30-degree angle on this graph, what's going to happen is I have a right triangle that looks like this. 30-degree, 60-degree, and I know that this length is square root of 3 over 2, and I know that this height is 1/2. So if I want to represent a 30-degree angle graphically, what I'm going to do is I'm just going to consider this ordered pair. Now, by the way, let me clarify. I need the unit circle to have a radius of 1 because the triangles that I'm using to create the angles have hypotenuses of 1. Right? So I can represent a 30-degree angle by this ordered pair. My x value is square root of 3 over 2. My y value is 1/2. And again, if I see this, this is a 30-degree angle on the graph. Okay. So I'm going to erase this. And let's make a 45-degree angle on our graph. I grabbed the eraser not to use it. All right, let's make our 45-degree angle. So again, I'm going to put my triangle in here, but I'm going to flip it around a little bit. I'm going to draw it like this. There's my 90, there's my 45. Here's my 45. And so I want to represent this 45-degree angle by explaining how I get to that point on the unit circle. So I know that I have to go over the square root of 2 over 2 to the right, and I have to rise square root of 2 over 2 up. And again, if I'm going to represent a 45-degree angle, I'm going to represent it like so on the graph. Square root of 2 over 2, comma, square root of 2 over 2. This is my 45-degree angle. Okay, let me erase this. Let me show you how I'm going to make my 60-degree angle. Now, hopefully this is making sense to you because again, you know, I had a hard time understanding when I was learning about trig, what the importance of the unit circle was. And again, the importance of the unit circle is it allows you to graph angles. Okay, it's not so clear how to put angles, but someone realized that if they made all the right triangles have hypotenuse 1, you can then represent the angle as an ordered pair. Really, actually quite a smart way to do it. So if I go like this, and I come up at 60 degrees, and I put my 30 degrees here, and I put in the side length, so I know that you're 1/2, and you're square root of 3 over 2. In order to represent a 60-degree angle on a graph, I just talk about this order pair. 1/2, comma, square root of 3 over 2. Okay, that is my 60-degree angle. So hopefully this is making sense to you guys. Okay, let me erase this. Okay, now 0, 1, that's my 90-degree angle. Okay, and 1, 0, that's 0 degrees. Now if I was to take my triangle and I was to, how am I going to write it on this one? I'm going to draw it like this. Okay. So there's my 60 degree, right? But let me fill in the blanks here. This is a 1/2. This is square root of 3 over 2. But in actuality, we're not calling this a 60-degree angle. This is what we're going to call our 120-degree angle. And let me explain why this is 120 degrees. Because this 60 degrees and this value right here have to add up to 90 degrees. So that forces this to be 30 degrees. So I've gone 30 degrees past 90. That's why it's 120 degrees. So if I want to represent a 120-degree angle on the coordinate plane, I'm going to represent it with the coordinates. And I have to use negative. So this is going to be negative 1/2. And it's not a negative length in this sense. it's saying that I'm going in the negative direction. So negative 1/2 and then square root of 3 over 2. So this would be how I represent a 120-degree angle. Okay. Let me do the next triangle here. Let's see here. Let's make this guy. So I'm going to do my 45, 45, 90. But I know that this angle right here must also be 45 because these two angles together add to 90. And so I just created a 135-degree angle, right? And so again, I represent this 135-degree angle using the coordinates, which are the side lengths of my triangle. So this is going to be square root of 2 over 2, square root of 2 over 2. And to represent a 135-degree angle, it's going to be the order pair, square root of 2 over 2. Negative square root of 2 over 2, comma, square root of 2 over 2. Okay? And that's how I represent a 135-degree angle on a graph. All right, let's just do one more here. Actually, two more, I lied. And I keep erasing this too much. Should use my fingers. Okay, so I'm going to draw one more triangle. That was terrible. Try this again. So I put a 30 there, which implies that that must be 60. There's my other 60. This is a square root of 3 over 2. This is a 1/2. And so I've just now created an angle that's 150 degrees, right? And I'm going to represent this 150-degree angle by the coordinates of the point on the unit circle. And so if I'm talking about a 150-degree angle, I'm talking about negative square root of 3 over 2 and a positive 1/2. This is my 150-degree angle. Okay. And I'll just talk about one more angle here. And it would be this angle, which is 180 degrees. And if I want to talk about 180 degrees, I talk about the coordinates negative 1, 0. So yeah, I guess I do have a homework assignment. Your homework assignment is going to be to find the coordinates of the rest of these angles. Now, we can call this 0 degrees, and we'll see here at the end of the assignment, we can also call this 360 degrees. So I would actually like you guys to continue this through quadrant 3 and quadrant 4. Hopefully this makes a little bit of sense to you of how we represent graphs on the coordinate plane. And again, I hope everyone's doing well up there. I'll see you guys later. Bye-bye.